Let's take a look at a low voltage battery disconnect. Now, this workbench here is off grid, and I'm running it on a 12 volt lead acid battery and a solar panel. Now, everything on the bench is 12 volts. My soldering iron is 12 volts. I have a power supply that I can actually get 24 volts out of, but it runs off of 12 volts. And I have, everything else is, the lights are 12 volt LEDs. So the whole thing's running 12 volts. Now, if I leave something on and the battery goes dead, if you bring the battery voltage down below, say 10.5, 11 volts on these lead acid batteries, it shortens the life of the battery, and it might not come back. So I want to be able to turn the battery off if I happen to leave the load on, or if the battery voltage gets below, say, 11 volts. So what I'm doing here is I have, over here I have a 5 volt voltage regulator. This way I'm running the controls off of 5 volts. That way if the battery is down to 10 volts or so, I'll still have my 5 volts here. And then I have a comparator here, and it's just an LM339. And for my reference voltage here, I have these couple 10K resistors here. Now that would give me 2.5 volts out here. But I have a feedback resistor here, and that's going to give me my hysteresis. So I have if the battery voltage is higher than the reference voltage, then this pin here, pin 2, is going to go to ground. When that goes to ground, this resistor here is going to be in parallel with this 10K resistor here. So I have it's adjustable, but I have, say it's 50K and 10K here. That means this is going to be about an 8K resistor, and this is going to be a 10K. And then I have a voltage divider, and it's going to change my reference voltage here. When this pin here goes lower than the reference value, output will go high. It'll go up to the rail here, and that puts this resistor across this resistor in parallel. And so now I have 8K here and say 10K down here. So, and that's going to change the reference value. So that's going to give me my hysteresis. It's going to turn it on and off when I want to. Now, as far as the battery coming in, I have a voltage divider here, and at 12.5 volts, this voltage divider is going to give me 2.68 volts over here. And when it drops down to 10.5 volts, it's going to give me 2.58 volts over here. And so I'm going to compare that to my reference value here and turn the battery on and off with that. Now, in fact, I changed this already. I think this is a 10.2K, so you can change these values to get whatever voltage you want to turn the battery on and off at. And this one's going to be a variable one, and I think I'm going to put a variable a pot in a couple of these too, so I can adjust everything. So when the voltage of the battery is higher than the reference value here, then the output here goes low, and when it goes low, I have a P-channel MOSFET out here, and the P-channel will turn on when the gate goes to ground, so that's going to turn on, and then that's going to supply come over to a N-channel MOSFET, and it's going to put voltage on the gate, and the gate's going to turn on, and it's going to turn my load on. Now on here I have a resistor and a capacitor across the gate here. So a capacitor from the gate to ground, and then I have a 220K resistor. Now that's probably what I'll go with. I've changed them because what this does is give me a time delay when it starts up. So this capacitor has to charge up through this resistor, and before the N-channel MOSFET can turn on. So what happens if the load shuts off, if the battery voltage drops below my, say, 11 volts, the load shuts off. But when it does that, the battery tries to recover. The voltage will spike back up, and I'm going to have it turn back on at about 13 volts, but it might spike up higher than that for a few seconds, and then settle back down. So I'm going to have a time delay on here. So even if this turns on, that the load won't turn back on. Otherwise, I'll have the load will be on and off and on and off. So we don't want that. So I'm having a little time delay here, just with a resistor and a capacitor across the gate to ground on the N-channel MOSFET. So let's see if it works. We'll we'll give it a try here. Turn that on. Turn that on. So I've got 10 volts coming in there, and oh, there it goes. Let me turn that back down. All right, try it again. 11, 12. 13, yeah, and then this is when the comparator turns on, and then the load comes on. So comparator is off, and then the load goes off. So turn it back on. It turns on at 13.8 volts or so. I'm gonna adjust that so that it'll come back at, say, maybe 13, and then the load comes on. And when the voltage drops back down, let's see when it shuts off here. Comes on, and this thing doesn't react that fast. So it's about 12 volts. So it shuts off at 12. I'm going to make it shut off at 11 and maybe come on at 13. But it looks like the circuit's going to work. And if I put in adjustable pots in there, I'll be able to adjust the hysteresis there, and when I turn it on and off my load there. So yeah, that should work good. This one here, this MOSFET, it's only good for 12 volts, 12 amps, I mean. But I'll probably get a better one there and put a heat sink on it. This one here is, I got a number on this. This is kind of overkill. I just happen to have this. This was the only P channel I had. It does no load on this one, so anything will work on there. And you probably go with the NPN transistor if you want. But I happen to have that one, so we went that way. And so this should work. Now I have I've done a couple other ones. I've done one with an Arduino and one with just transistors, and I'll put links to those two in there. The one with the Arduino, it seems to work good. It's been working on the project I had for a couple of years now. But this one here, I thought I'd try this one out, and I had all the parts for it. So that's it. That's the low voltage battery disconnect. Thank you.